Hello, everyone. Good morning, and I welcome you all into today's discussion. Now, with respect to today's tutorial, we are going to look at portfolio minimization in the case of three assets. So let's suppose we have three different assets, that is A, B, and C, with their respective returns and volatility. And we've been asked to find the weight of A, B, and C that minimize the portfolio. So just like the one that we did in the previous discussion, and that we had two assets, and we were asked to find the weight for the two. So in this case, we have three assets, and we've been asked to also find the weight. So what we have to do is first to define our problem, which is so what we are looking at now is we want to minimize the variance or the volatility of the portfolio subject to two constraints. That is, first, when you sum up the weights of A, B, C, that should be equal to 1. And when you multiply the weights of individual assets by their respective returns, and you sum up, that should also be the same as what the portfolio returns. So first of all, what we have to do is to set up our Lagrangian function, which is what I've done here. So the Lagrangian function is just trying to write the portfolio variance, and you subject it on the two constraints. So if you check these first three, these ones up to this point, it's the same as the portfolio variance. So it's just that what is saying that the weight of A squared multiplied by the volatility of multiplied by the variance of A plus the weight of B squared multiplied by the variance of B plus the weight of C squared multiplied by variance of C plus 2xAB multiplied by the covariance of A and B. So that expression represent the one that I have underlined, represent the formula for volatility of a portfolio. And we are now subjecting it on a constraint. And then because it is what risk minimization, because we always try to minimize risk, we don't maximize. That is why I've also introduced the minus here, minus lambda, and then you subject it onto what the portfolio returns. So what we are saying here is that when I multiply return of A by the weight of A plus return of B multiplied by the weight of B and that of C multiplied by the return of C, that will be the same as what the portfolio returned. And the minus lambda 2 also is looking at the weight. So I've just constrained these two on the portfolio. So what I'm going to do now, the next step is just to differentiate. So the information that we are looking for now is, so let's go to the next slide. Great. So now we have the Lagrangian to be a function of what xa, xb, xc, lambda 1, lambda 2. So these are the information that we do not know. So if you have information like this and you're trying to minimize, then what you first do is what you differentiate your Lagrangian respect to A, B, C, lambda 1, lambda 2, and you set it to be 0, right? So when you look at the first one here, I'm differentiating the Lagrangian function with respect to A. So when you look at the first component of the Lagrangian function, which is this one, let's go back. Which is this one. Great. So in this one, if I differentiate the Lagrangian respect to A, this expression is going to be 2xa variance of A, right? And this expression, there's no A here, so I don't differentiate this. There's no A here, I don't differentiate this. But when you come to the fourth component, I have A there. So when I differentiate respect to A, I'm going to have 2xb covariance of AB. And when you look at the fifth component too, when you differentiate, you have 2xa, you have 2xa, xc. So when you differentiate, you're going to have a 2xc covariance of A and C. Now, when you come to this expression to this part, I have RA lambda A. So when I differentiate RA XA, I'm going to have what? RA, but there's a minus, is minus RA lambda 1. Now, when I come here to this, also XA here, right? So when I differentiate this respect to XA, this expression is going to give me 1. So 1 times lambda minus lambda is going to be minus lambda 2, right? So when you look at the expression, that is exactly what I have here. So that is what I have here. So when I differentiate respect to A, this is what I'm getting, 2xa variance of A plus 2xb variance of B. So let's take a look at the second, the B part again. So let's look at the B. So if I'm going to differentiate the same Lagrangian function with respect to B, then in the first component, there's no B here, so I don't touch it. But in the second component, there's B. So when I differentiate with respect to B, I'm going to have 2xB variance of B, right? In the third component, there's no B. But when I go to the fourth component, I have 2xAxB. So when I differentiate 2xAxB, I'm going to have 2xa covariance of A and B. Now, when you look at the sixth component, that is, you have 2xBxC, right? So when I differentiate with respect to B, I'm going to have 2xCBC. Now, when I come to minus lambda one side, when I differentiate with respect to B, I'm going to have what, minus B lambda one. And when I differentiate with respect to in the second other one, I have what, I'm going to have minus lambda 2. So, and that is exactly the same thing that we've got in here, which is also the same as this one. So the third one also looks at what differentiate respect to xc. And the fourth one is differentiating respect to lambda. So let's look at that one too. So when I differentiate respect to lambda 1, look at something from here. So in the first, when you look at the first 5 components, yeah, there's no lambda 1 there. So that part, I don't touch it. It's like almost 0. Now when you look at the other one, when I differentiate respect to lambda 1, I'm going to have what, minus bracket RASA minus RBSB minus RCSC. It's okay, minus mu P, right? And when I differentiate respect to lambda 2, I'm going to have only what, x minus XA minus SB minus XC plus 1. And that is exactly what I've also done here. That is exactly what I've done here. And that is also giving me this one, right? So now what we are coming to do here is we are trying to represent this information with metrics. We are just trying to represent everything here on metrics. Now look at something. So let's take a look at the first one, 2xa, right? So let's say I'm going to start everything from I'm going to start everything from the first part, the first equation. So it's 2xa variance of A, 2sb variance of B. I just want to write this in a matrix form. So let's come to this point. So when you look at the diagram that I've done, I'm just saying that any component with XA should fall under this section, and any component with SB should also fall under this section, and any component with XA should fall under this section, and any component with lambda 1, lambda 2 should also fall under this section. Great. So that's what we are coming to look at. Now, so when you check the first equation again, we had it as what? 2xa variance of A plus 2sb covariance of AB plus 2xc covariance of AC minus lambda 1 minus RA lambda 2, right? So when you check that equation, that is equation 1, I have 2xa, right? So I'm going to write the information attached to the 2xa. So I'm going to have here 2, sorry, I'm going to write there as 2 variance of A. Then I will put the XA here. So that when I multiply this by this, it gives me the same information again, right? So if I multiply this by this, it's going to give me the 2XA variance of A that I have already. Now, when I check, the next one that I had there was what that had B in it was 2XB covariance of AB. So I'm going to write on the 2 covariance of AB. Then I'll bring the SB here, right? So when I multiply this also by this, it gives me this. It's okay. Now the next one that had C in it also 2XCA covariance of AC. So I'm going to have 2 covariance of AC. And I'll bring the XC here. So when I multiply this by this, it gives me 2XC covariance of AC. That is, if I multiply this by this, that gives me 2XC AC. Great. So the next one that we are looking at is what, and that what has lambda 1 in it. So it was just minus lambda 1, right? Minus lambda 1. So I'm going to write minus 1 here, and I'll bring my lambda 1. So when I multiply this one by this, it gives me this. Is okay. So let's check the equation again. Right, great. So the next one that we are looking at is the one that has lambda 2 in it. And the one that has lambda 2 in it was what? Minus RA lambda 2. That is what we had. So that means when I write the minus RA here, then I'll bring my lambda 2 also here, right? So what I've done here is that when I multiply the information here by the information here, it should give me the equation again, right? And after that, it should be equal to 0. So I'll write a 0 here because there was an equal sign saying everything equals to 0. So I write a 0 here. Great. So now when you go to the second equation 2, that is LSB, the one we differentiate with respect to SB. So you are going to ensure that everything that has A in it is also written under this column, like I said. So when you go there, the one that had A in it was 2XA covariance of AB. Then I'm going to write 2 covariance of AB, right? I've already written the AC here, so there's no point in writing it. So once I multiply this by this, I'll get this. Now the one that had B attached to it was in the equation 2. The one that was 2SB variance of B. That means I'm going to write 2 variance of B. Because so when multiply by that gives the same thing. And the one that had C attached to it, the one that had C also attached to it was BC, 2XC covariance BC. So I'm going to write 2 covariance BC. Then XC is here, right? And the next one was what? The lambda. So the lambda in that case was also what? Minus 1 lambda. So minus 1. And the next one was what? RB minus RB. That gives me this. Is okay. Now let's look at the equation 3. That is when we differentiate with respect to XC. The one that has A attached to it is what? 2XA covariance of AC. That gives me 2XA covariance of what? AC. So the XA is already here. Now the next one that had B attached to it was the one that had B attached to it was equation 3, right? Great. The one that had B attached to it was 2SB covariance of BC. So I'm going to write 2 covariance of BC, right? And then the X is also here. And the next one that had C attached to it. Okay, so sorry, the fourth, this one's supposed to be the one that had B attached to it. So that's what I have done. So great, the one that has C attached to it is what? 2XC variance of C. So I'm going to have 2 variance of C. So the X is here. And then the minus, the lambda was what? Minus 1. And then minus RC is okay. Great. Now let's look at the second equation, the fourth equation. The fourth equation, we have it as, but this one is also equals to 0. At the end of it was equals to 0, right? Now let's look at the fourth equation. The fourth equation, we had it as L lambda 1. So we said L lambda 1, we had L lambda 1 is equals to minus XA minus XB minus XC plus 1 equals to 0, right? So this can also be written as XA plus SB plus XC equals to 1, right? This one can also be written as this one. So great. So then I've reformed this into this. So I'm going to do this. Now when I look at this one, this is XA, right? So XA here, it means this is going to be 1. From the fourth equation with the lambda 1 is going to be what? 1. And SB is going to be 1. And X is going to be 1. But we don't have any information of lambda 1 in equation 2, in equation 4. So it's going to be 0 here. And there's no information with lambda 2 in equation 4, so also going to be 0 here. But after the equals, and I have it as what? 1. So I do the same thing for the fifth equation, which was the one we differentiated with respect to what? Lambda 2. So when I write it, the same thing I'm going to have. So in that case, we're also going to have first, it is going to be RA, RB, RC is okay, but there's no information of lambda 1 and lambda 2 in this. And this one also gives what the mu of the portfolio is okay. So we've been able to represent the information in the equation as sort of matrix. So we can call this one as what? Matrix A. Let's call this one as matrix S. And let's call this one as matrix B, right? So then I can write this expression as AX, matrix of AX equals to B. Now, if I'm looking for X, in this case, X represents the weight, right? And the lambda 1, lambda 2. And I can say S is equals to A inverse multiplied by B. And up to this point, you have to use Excel because you have information of a 5 by 5 matrix. And with 5 by 5 matrix, you can't do that manually. So you're supposed to use Excel. Now, once you use Excel to solve it, you are going to have it. The final answer that you're going to get for X here is going to be 5 by 1 matrix. It's okay. So with the 5 by 1 matrix, I'm going to have the X here. In this case, is going to be XA, SB, XC, lambda 1, and lambda 2, right? So that will mean that this, after multiplying this by this, the matrix B here in this case represents the 0, 0, 1, 0, 0, 0, 1, and the mu of the portfolio. So when you solve, and it gives you the 5 by 1 matrix, then the first three information here represents what your weight that you are interested in. I hope it's okay. And thank you. And do not forget to subscribe to my videos. So in our next discussion, we look at how you are going to look for weights, and that will help you to reduce all risk or to get a risk of 0. Thank you. Do not forget to subscribe to my video once again.